Is a video tutorial on exponential functions. An exponential function is a constant raised to the power of x. So for example, here are a few that you can see. And the main thing you need to understand, or the mistake that I often see with students, is that they mistake this for x to the power of 2, or in this case, x to the power of 8. These two are not the same. So in general, it's just any number to the power of x. The general shape or the appearance of an exponential function are these two here. It's called an exponential function because as it moves along, it gets steeper and steeper very quickly. When it's a negative x, notice how it's kind of like a reflection of the original, which does this one. That it's actually one of the key features that we'll be going through here. So let's get to it. So the first key feature is that the larger the value of a, the steeper the graph. So for example, if this were y equals 2 to the power of x, if it was y equals 8 to the power of x, it would be so this is 2 to the power of x, and 8 to the power of x would look something like this. Obviously, minus that little jitter there. The x-axis, or the line y equals 0, so in this case, this purple line here, or here, is known as the asymptote. An asymptote is a line that the function approaches but never touching. So for example, zooming in here actually, even though it appears that this line will eventually go through this purple line, what is actually happening is that it's getting closer and closer, ever closer and closer, but it will just never hit that purple line. That is called an asymptote. For positive values of a, the graph remains above the asymptote, and for negative values of a, the graph remains below the asymptote. So this here is positive a to the power of x. It's above the asymptote. But if that value of a was negative a to the power of x, it would look like this, below the x-axis. Same goes for this one. If this was negative a to the power of negative x, it would look like this. It's a reflection of this one. This one I've already noted, that a to the power of negative x is a reflection of a to the power of x. So this is the regular graph. If we now make x negative, it would be a reflection like this. So if I draw both of them, that's the regular. A to the power of negative x would be a reflection like so. And lastly, the regular function always passes through 0, 1. So it'll always pass through this point here. Now let's do a few examples here. I've actually already filled out these tables of values because it takes quite a while to do them. But I invite you to try and type these out yourselves, and I'm going to demonstrate to you a few here because there's a common mistake that students make when typing these out. So go ahead, pause the video, and fill out your own table of values using your own calculator, and try draw these out yourself. Okay, so here we go. Whoops. I'll just demonstrate a few. 2 to the power of negative 3 should be typed out like this. 2 to the power of should be a box like so, to the power of negative 3. And as you can see, you get 0.125. Okay, so 2 to the power of 3, clearing this. 2 to the power of positive 3. Whoops. That gets us 8. Graphing these, we should plot the points first. 0, 1. 0, 1 is about halfway. 1, 2. 1, 2. 2, 4. 2, 4. And 3, 8. 3, 8. As for the negative values, it's very difficult graphing them, so it's best just to make it as close to the x-axis as possible. In actual fact, I kind of just draw a line like so, as closely as I can to the x-axis. When you graph these, it should be as smooth of a curve as you can make it. And there we have it. Let's do it for this one as well. 0, 1, 1, 4. Let's do 2 at a time. 0, 1. So that's 0, 2, 0, 1 would be about there. 1, 4. 2, 16, I believe. 2, 16, 3, 64. 2, 16, 3, and 64 all the way up there. Notice how you can see. Let's just graph these ones first. You can see that because the base value is larger, so this one was 2 to the power of x, and this is 4 to the power of x, you can see that one is definitely steeper than the other. Let's just finish this off. I'm just going to draw a straight line as closely as I can to the x-axis. There we go. Let's do it again. Pause the video and typing these out yourselves. Make sure you match these values that I have. Make sure you're typing them in correctly. Graphing these out. -3, 11. So -3, 11. These are going up by 2s, so 11 should be here. -2, 7, sorry. -2, 7. -1, 5. 0, 4. 1, 3.5. 2, 3.25. And this one, next one is 3.125. So it's even closer and closer to the number 3. So the graph should look somewhat, oops. Hope you're using pencil for this. For this one, again, I'm just going to kind of draw a straight line on that line 3. Notice how the values are getting closer and closer to 3, meaning our asymptote has moved up to this line, y equals 3. So it should be a line approaching like so. Let me redraw this one. So it should look actually somewhat like so. And there we have it. Okay, graphing these out again. Again, I invite you to try and type these out into your calculator. That's the main skill that most students have trouble with here. So 3, 124, It's off the charts. Negative 2, 24, graphing this out. Negative 2, 24 is close to 25, so it should be like this. Negative 1, 4, graphing this one. Negative 1, 4, 0, 0, 1, 0, negative 0.8, 1, 0.8, so 2.5 would be here, so it's super duper close, like so. In actual fact, all of these are very close to negative 1, which is where our asymptote would be. So the asymptote would be along this line here. And these points along the line, these points are getting closer and closer to that asymptote, like so. And the growth is like so. And this is off the chart, so I'm just gonna kind of draw. And there we have it. One last one. Once again, I invite you to pause the video and try and type these out into your calculator yourself. That's the main skill that you'll get from this. Graphing these out, let's just do the whole numbers for now. 0, 1, 1, 0, 2, negative 2. Oops, sorry, looked the wrong way. Sorry, 0, 1 is above, so it should be here. 1, 0, 2, negative 2, 3, negative 6. So in this case, it's actually going downwards, like so. Oops. And the asymptote here is that plus 2. So there's actually, again, that imaginary horizontal line. It's been moved up because of this plus 2. The lines are getting closer and closer to that value, like so. One last one, graphing these. Negative 3, negative 29. 29 would be very close to 30, so something like this. Oops. 2, negative 2, 11. Negative 2, 11, that's 10, 11 would be there, so let's graph that. These are just approximations, by the way. It's the general shape that we are looking for here. Negative 1, negative 5, negative 1, negative 5, 0, 3, 1, negative 2.3. Ooh, that's 2, it's 1. So it's actually getting very close to the number 2. Notice how they're getting closer and closer to negative 2. This means that our asymptote is along the line negative 2. So let's draw that imaginary line in purple. And that's what our line, our curve, sorry, is getting closer and closer to. So joining our curve should look somewhat like this. Oops. This is the line that it gets closer and closer to without ever touching. So I hope that gave you an insight into graphing out exponential functions and typing them out into your calculator. Hope to see you in the next video. Best of luck.